Today we're going to talk about complex numbers. Complex numbers uses the imaginary unit I. So a complex number contains the quote-unquote number I. So anytime you see I, it is not a letter or a variable. It is a numerical value. It represents the square root of -1. So I is the imaginary unit that equals the square root of -1. If I were to write a complex number in standard form, so the standard form of a complex number is a plus bi. Okay, this would be my constant term, or the term without the imaginary unit I in it comes first. So real comes first and then the imaginary. Okay, some things you also should know and probably maybe learned last year is I squared is equal to -1. I cubed equals I, and I to the 4th equals 1. Yes, my I's look like backwards J's. I do that for me, so when I am writing them, I am aware of the fact that it is not a number, so I know it's not a 1. It is definitely an I. Okay, let's look at a few. So when we're dealing with the imaginary unit, we're looking at it here with the square roots. Some of the ones that we're going to do is right here. So like the square root of -5. Well, we've been taught we can't do that, but an imaginary unit makes it possible. So we can say this is the square root of -1 times the square root of 5. All right. By doing that, I understand that the square root of -1 is I. Square root of 5 can't be simplified, so we leave him alone as square root of 5. Okay? And I understand plus or minus goes out front. And that's it. Now my number is simplified. If I look at something like this one, square root of -8, I'm going to follow the same process. So I understand that there's a square root of -1 and a square root of 8 in this. But 8 can be simplified. So I have the square root of -1, and then I'm going to have the square root of 4 times the square root of 2. Notice that 4 times 2 does give me 8, and 4 is my perfect square. So when I go to simplify this, I'm going to have I, right, times 2 times the square root of 2. All right, I wouldn't leave it like that. That's not in standard form. So if I wanted to write it neatly, it would be 2i square root of 2. And again, plus or minus goes out front. So again, there's my I using my 8, and I simplified it down. The next one I want to look at is this one here. It's the square root of -4. Break it down. Square root -1 times the square root of 4. I don't need to break down 4 because unlike 8 was not a perfect square, 4 is. So because of that, I know this one is I and this one is 2. Again, it's not how I would write it, but we are going to write it as 2i, and we're going to put our plus or minus out front. And that's it. That's how we handle square roots that are negative with the I. Okay, so then sometimes problems get bigger, something like this. And I look at it and I say, well, I need this. Oops, that's not what I wanted to do, guys. I apologize. That's the one I wanted. This right here is a negative, and I need to simplify that. So this part stays the same. Let's do this all in one shot. It's 9. Square root of 9 is 3. Because it is negative, we say 3i. Now this time I'm not going to use plus or minus. And the reason is it's already in an expression. The symbol out front is already telling me which one I want. So I want the positive one, so it is there. Okay, so let's look at the next ones. These are a little bit bigger. Looking at both of my square roots, they can be simplified. So let's do that. This is going to be square root -1, and it's 20. So what number in 20 is a perfect square? I would hope by this point we know it's 4 and 5. would be the 2 that I want, plus, let's do 30, negative 1. And in 30, do I have a perfect square? I don't believe so. So it's probably just the square root of 30. Okay, so we're going to simplify this. This is going to be 2i square root of 5 plus I square root of 30. Okay, so let's talk about some other things. These two things are not like terms. This has an I, and this one does not. This is imaginary, this is real. Okay, so because of that, that's as simplified as it gets. Over here, the same thing. They both have an I, but my radicals are different. If these were both square roots of 5s, I could combine them, but they're not, so I would leave them alone. So like terms, it has the same exact variable with the exact same exponent. So we're stretching the term variable. I want to replace that with imaginary. So if they're both imaginary, then they're like terms and I can combine them. So in this problem here, this is asking me to take these values and add them to these values. So this is 3 minus 7, and then 9i plus 2i, and this was positive. So this gives me negative 4 plus 11i. Notice how I put the two like things together, both the real numbers together and both the imaginary units together. Combined, that will give me my answer. This is it. It's as simplified as it can get. Let's look at subtraction. So in subtraction, remember I got to distribute that negative. So when I look at this, this is 5 plus 8i. And when I distribute that negative, it's going to become positive 3 minus I. Yes, positive 3 minus I. I notice this is my I term, this is my I term, this is my real part, this is my real part. And I'm going to go ahead and combine them. So this is an 8, because 5 plus 3 is 8. 8i minus I is a plus 7i. And that's as simplified as it gets. And that is my answer. So remember, subtraction, we just need to distribute that negative and then collect the like terms. And this last one is multiplication. And multiplication is handled the same way we have always handled multiplication. I like to do in order, so I want to multiply these two numbers together, and that's going to give me negative 6. I then want to multiply these two numbers together, and that's going to give me a positive 4i. I'm going to go these two numbers here, and that's going to give me a positive 12i. And then these last numbers here, that's going to give me a negative 8i and squared, because I times I is I squared. Okay. We're going to try to simplify this and look. So these two things right there, they're like terms, right? They both have an imaginary unit. I can combine them. So I'm down to negative 6, plus 16i minus 8i squared. And now I want you to remember, back in the beginning, I said you should know some things. And we said that I squared equals negative 1. All right, that means anytime I see an I squared, I replace it with negative 1. So this is negative 6 plus 16i minus 8. And right in here is where the negative 1's going to go. Okay, I would simplify that. Negative 6 plus 16i plus 8. All right, because a negative 8 times a negative 1 is a positive 8. And then combine my like terms again. Notice, doing so, I have two real parts again. So they have to be combined. And remember, real goes first. So 2 plus 16i. And that would be it. That's my answer. If you have any questions, join our Google Meet and come talk to me. Or you can email me, but come see me and get the help if you need any. Thanks.